Hi guys, this is Jonathan Lambert with Maths and Stats, and in this video, another video in our series of videos dealing with calculus and specifically concentrating on limits, and in particular epsilon-delta proofs, is going to present an epsilon-delta proof that shows that the limit of 3x plus 4 as x tends to 2 is equal to 10. Okay? Let's just recall our definition of a limit. So let's just recall the definition of a limit, which says this is that given an epsilon greater than 0, okay, there exists a delta greater than 0 such that for each and every x, let's just write that down here, for each and every x satisfying the condition that x minus a, okay, so what we really should be saying here is that given a function f, that the limit of f as x tends to a, okay, exists if given any epsilon delta is greater than 0, there exists a delta greater than 0, such that for each and every x satisfying this condition here, so for each and every x that's less than delta, that implies that f of x minus L is less than epsilon. So in their situation here, okay, so in this case, okay, what we need to do is that given an epsilon greater than 0, okay, we need to find a delta greater than 0 such that for each and every x satisfying this particular inequality, that 0 is less than x minus a, a is where the limit is tending to, so x, this is the a value here, so x minus 2 has to be less than delta, that needs to imply that f of x, well, f of x is just 3x plus 4, okay, minus L, minus the limit 10, okay, has to be less than epsilon, okay. So we need to find this particular delta, okay? And this delta has this particular condition that all x within this particular, that satisfies this inequality, that all x that satisfies this inequality implies this particular fact here. So how do we find an appropriate x? Well, we need to satisfy this particular fact, okay, at the end, this implication, okay, its premise and its conclusion, okay, that whatever x are in this region, yeah, that has to imply this particular thing here. So let's just consider, so in these proofs, what we're always going to do first is we're going to consider the conclusion, okay, of the implication, okay, in which case what we have here is we're going to consider f of x minus L less than epsilon, and we're going to try to find an x value from this that satisfies that's less than some particular value. Okay? So we're going to consider this. So what we're considering, we're considering 3x plus 4, the absolute value of 3x plus 4 minus 10 has to be less than epsilon. Well, what does that tell us? And what we're going to do is we're going to try to reduce this, okay, into this particular form. So we're going to try to reduce this thing down to x minus 2, okay, within the absolute bars. So this becomes 3x, the absolute value of 3x plus 4 minus 10 has to be less than epsilon, which is 3x minus 6 has to be less than epsilon. We want to try to get this to look something like this, x minus 2. Oh, if we take a 3 out, that's common here. So this is 3 times x minus 2. The absolute value of that is less than epsilon. What does this tell us? Well, this tells us that the absolute value of 3 times the absolute value of